To understand artificial intelligence, you need to have an idea of how neural networks work. There are multiple types of neural networks. In this video, I cover dense neural networks and follow the discussion on how it relates to chatbots like ChatGPT. I said you need to have an idea about how neural networks work. Let me give you a simple example from the past where simple understanding can make a big difference. Everybody has used a browser to access web pages on the internet. You use one on your phone, tablet, and computer. This was the original purpose of this software, read and display files. It also allowed to pass parameters to tailor what's returned. Very quickly, people saw an opportunity to use this to write applications. Here's an example of a web page address called a URL or Uniform Resource Locator. What you see here assumes a communication protocol, so in this case it assumes that the communication protocol used is HTTP. In the example here, it also uses encryption for the communication. The protocol was considered light and efficient. People were saying HTTP is a stateless protocol that is very efficient and can support large number of users. This was true for serving files, and many people left it at that. HTTP is an efficient stateless protocol. You create a URL, send a request to a web server, and quickly get what you ask for. The problem is that to support applications, you need to maintain information over time. For example, you don't want to provide a username and password on every call. Applications also need to allocate resources that will last for the length of the user's interactions. For example, an application may need to create a database connection. If the communication is stateless, each communication opens and closes a database connection. So when companies took a browser that was created to retrieve and display files, it used it to serve applications. It created a new industry of companies providing what was called application servers to work around the issues of using stateless protocol and create contexts that live longer than one interaction, but would go away after a specified amount of time if the user was not heard from. There are simple things to know about neural networks that may give you a feel for the current limitations. So let's look at a neural network. Keep in mind that I'm keeping it high level, so there are details missing that are not required to understand what is happening. Neural networks neurons, also called perceptrons. They receive an input, process it, and generate an output that is passed to the next layer of neurons. A neuron receives multiple inputs. This could be values such as age, income, time of the job, and so on. In the case of chatbots, it would be encoded words. The processing simply applies a weight to each input and adds them up together. The formula used is a linear equation. As the name implies, a linear equation would be represented graphically as a straight line. Once a neuron completes the calculation, it passes it through what is called an activation function. The resulting value is passed to the next layer of neurons. As you may have guessed, there are multiple neurons at each layer. Let's add a little bit of terminology. The first layer that provides the input values is called the input layer. In the case of a dense network, as represented here, each value is passed to each neuron. The layers following the input one are called hidden layers, up to the last layer that is called the output layer. Here we show only one hidden layer, but there are usually multiple ones. One thing I have not mentioned yet is the possibility of using what is called a dropout layer. The dropout layer picks a percentage of neurons' values coming in and resets them to 0. The selection is done randomly. The rationale is that it removes the possibility of specific neurons having too much impact on the final result. The process of going from the input value to the output value is called forward propagation. When we train a neural network, we have an additional process called backpropagation. You can understand backpropagation as the process of taking the difference between the generated value and the expected value and propagate back proportionally through the layers to adjust the weights so the next time the generated value will be closer to the expected one. This weight adjustment is done in small increments as not to pass over the optimal weights values. In the MIT Introduction to Deep Learning, Alexander Amini said the world is extremely nonlinear. When we look at the neural network, it is mainly a large linear equation. What makes it nonlinear is the use of activation function. This is quite an appropriate name since if they are removed, the neural network would not do anything interesting. On the right side of the slide, you can see graphical representations of a few activation functions. These graphs gives you an idea of how the output value is modified before being passed to the next layer. The term nonlinear is never defined in the MIT lecture. According to Wikipedia, a nonlinear system is a system in which the change of the output is not proportional to the change of the input. Although such chaotic behavior may resemble random behavior, it is in fact non-random. Activation functions may not add randomness, but in my opinion, they do add unpredictability. On the other hand, dropout layers definitively add randomness to the result. This should give anyone pause on any unsupervised use of LLMs. Like they say in management, trust but verify. How does this relate to chatbots? Let's first start by reviewing the few names we hear related to it. The first one is Large Language Model, or LLM. This relates to the fact that these neural networks are trained using words and sentences, and the overall neural network is quite large, as we'll see shortly. The other term you see is Generative AI. As magical as chatbots like ChatGPT look like, their base functionality is to predict what would be the next word in a sequence. For example, if I ask you to give me the next word in Once Upon a, I'm pretty sure that the first word that comes to your mind is time. A chatbot assigns a statistical value to each possible word in its vocabulary and picks the most probable. The next term is Generative Pre-trained Transformers, or GPT. We already saw what generative is. The transformer word refers to a specific technology implemented in the neural network. As a user, the description of neural networks provided previously is sufficient, at least for now. The pre-trained part refers to the process described earlier that adjusts the weights using backpropagation. This is the most processing-intensive part of the training. Chatbots go through additional fine-tuning training and even something called reinforcement learning. You don't need to worry about this at this point. We also heard about agentic AI, that is a variation on what we saw. We used a toy neural network example that was easy to show graphically. The diagram showed 5 input neurons, 3 in the hidden layer, and 2 in the output layer for a total of 21 weights. The weights are also called parameters. Let's see how it compares to an older version of ChatGPT. GPT-3 came out in 2020. We see here that GPT-3 has 175 billion parameters. These are the weights we talked about earlier, where our example used 21. GPT-5 is said to have 3 to 5 trillion parameters. Note also that GPT-3 has 96 layers, many more than our simplistic example. GPT-3 was trained with close to 500 billion tokens. For simplicity, think of tokens as words. A chatbot is trained to figure out which word comes next, and the billions, if not trillions of weights are adjusted to provide the best statistical guess, just like when you guess that time followed once upon a. The chatbot pulls it out of its memory represented by the billions of parameters. What should you remember about chatbots? They are based on neural networks that take numbers as input. In fact, it takes a set of numbers to represent tokens that are more or less equivalent to words. Each neuron in each layer uses different weights for each input value. During the training phase, the weights, also called parameters, are adjusted to become better at predicting the right result, what the next word should be. The weights represent the knowledge of the network. It is its memory that it uses to make its predictions. A chatbot core functionality is to predict the next word based on all the word sequence it has learned from. We did not discuss the additional phase of training, but a chatbot learns patterns of questions and answers and can also learn to access the internet or even generate and run programs to provide answers. In some cases, it can result in hallucinations, false results, false reference, so trust but verify. At this point, AI should only be considered a useful tool. You can trust the results to an extent, but you should always apply critical thinking in case some errors are generated, as is regularly reported in news articles. Please comment on this video, and I'll see you next time on Bite-Sized Data Science.